Hi everyone, welcome back from spring break. I hope you had a great vacation and I hope you're ready to get back into your academics, specifically math. I know it's been a while since you've looked at trigonometry, so I'm going to do a brief review and then we're going to move on to today's lesson. So you have this diagram over here to the right. You've seen it many times. So what do we have? Hopefully you look at this and you remember, oh, this is called a unit circle. Why do we know it's a unit circle? Because it has a center at 0, 0, and it has a radius length of 1 that we can see here. Now, if we wanted to put any point along the circumference of this circle, we would start from the origin, go right some units, up some units, and that would create a right triangle right here. Now the angle measure to get to that radius, we would start from the positive x-axis, rotate that angle measure so we get this right triangle here. Now, in order to calculate the value of x and y, well, if you have a right triangle, you know SOHCAHTOA, right? So you remember SOHCAHTOA. So sine is equal to opposite over hypotenuse. Well, my opposite is y, my hypotenuse is 1. So in other words, sine was just equal to y. Cosine is equal to adjacent over hypotenuse, which is x over 1, or cosine is just equal to x. Now we know from geometry that this is a Pythagorean or a right triangle, and in a right triangle, we know that a squared or side squared plus side squared equals your hypotenuse squared. So we know that x squared plus y squared equals 1 squared. And if we substitute in these values, so instead of writing x, we can put in cosine because cosine equals x. When we do that, we find the Pythagorean identity. So if we substitute in for x, we would get cosine of theta squared. If we substitute in for y, substituting in y, we would get sine. So we get sine theta squared. And of course, 1 squared is just 1. So we would get cosine squared theta. You can also write it like this. Remember, cosine squared theta plus sine squared theta equals 1. So that is called the Pythagorean identity. Now the other thing that we learned earlier in the unit were these special case triangles. Remember that a 30, 60, 90 degree triangle that's coming from an equilateral triangle. If we make this equilateral triangle have a length 1, which is the side length of a right triangle here in a unit circle, then the side opposite pi over 6 would be 1/2 because we've split that down the middle with this altitude here. So this is 1/2. And then we proved with Pythagorean theorem that the side opposite pi over 3 would be √3 over 2. In an isosceles right triangle, we have a hypotenuse of 1. When we use the Pythagorean theorem, we found that each side length is either 1 over √2 or √2 over 2. So you can say either one, 1 over √2 or √2 over 2. All right, so now that we did a little review, here are our goals. We have 2 goals for this lesson. This first goal we will start with, and that will be about using cosine and sine to figure out information about points rotating in circles. And then after that, we'll be talking about periodicity, periodic functions, how you know something is periodic. It looks like a wave. So we'll talk about that in the second part of this lesson. All right, so let's jump into the first part of the lesson. I would love for you to pause. Again, what are we focused on here? We are trying to use cosine and sine to figure out information about points rotating in circles. So you can see we have a point right here rotating in circles. So let's get started, and why don't you pause and jot down some of your own notices and wonders. Okay, so if you are done, you can just check. Maybe you check with some people you're sitting around, but hopefully you noticed a few things. I hope you noticed that this triangle ABC has point A on the unit circle. How do I know it's a unit circle? Because it has a radius length of 1 and it is centered at the origin. So this specific one with triangle ABC is a unit circle. Hopefully you notice this point on the unit circle is -0.87 and 0.5. Just as a heads up, you probably did not know that 0.87 is the approximation. So root 3 over 2, if you plug that into your calculator, you get approximately 0.866. So 0.87 is an approximation of root 3 over 2. And then, of course, 0.5 is an approximation, an exact value for 1/2. So point A is also negative root 3 over 2 and 1/2, which you remember came from the unit circle if you went around the unit circle. We did that at one point during class. So another thing I hope you noticed is that this other triangle DEF is on a circle that is not a unit circle because it has a radius length of 2. But hopefully you're saying to yourself, well, that must mean that this circle is twice as big or twice as large as the other circle. How do I know that? Well, the radius length is twice as large. Hopefully you also notice that this is a right angle here, this is a right angle here, and that this angle measure theta is the same as this angle measure theta, which means this angle, blue angle here, and this blue angle here must be equal to each other. And if we have two angles congruent to each other, then that means that triangle ABC is similar to triangle DEF. And specifically triangle DEF, and that's true because of AA, and triangle DEF has a radius length or a hypotenuse of 2, which means it is twice as big. So maybe you're wondering how can I get this point D? Can I get a specific value for point D? And that answer is yes. Eventually, we will be using sine and cosine to find that value of D. But right now, you don't need to know that because you know you have similar triangles. So we can find that. It's points rotating around circles. So we rotated this point to here. We rotated, and we have that point here. But how could I find D specifically? Well, I hope that you realize I can just take the x coordinate and multiply it by 2, and I can take the y coordinate and multiply by 2 because it is twice as big. So we're just making those values twice as big. Let's do this one first. 1/2 times 2, that one's a little bit easier. So 1/2 times 2 is 1. And what is negative root 3 over 2 times 2? Well, that would be negative root 3. Or you could plug that into your calculator and get a decimal approximation. But we don't want you to do that. You can just leave it as negative root 3, and that's fine. So again, the first part of this lesson today will be trying to get ordered pairs on different circles. All right, so jumping to our next example, around a Ferris wheel. So we have the center of a Ferris wheel that is 40 feet off the ground, and the radius of the Ferris wheel is 30 feet. So here's a radius right here. So we know this is 30 feet, which means that this radius right here is also 30 feet. But if it's 40 feet off ground, so this center part is 40 feet off ground, that means this little green part here is how many feet? Well, hopefully you're saying to yourself, that's going to be 10, because 10 plus 30 is 40. Or in other words, we could say from here, from the center of the Ferris wheel all the way down to the ground, that's 40 feet. So it says, calculate how high off the ground point P is as the Ferris wheel rotates counterclockwise starting from 0 radians. So how can we do that? Well, it's going to rotate. So we have letter A. We're going to rotate pi over 12 radians. So this radius is rotating pi over 12 radians until we get to here. So this is my new point P. So we'll call that P prime because we've had a rotation. So we are trying to find the distance from this point P prime down to the ground. Well, hopefully you see that this distance here we already know is 40. So the piece that I need to find is this little yellow piece here, because then I can add 40 plus that little yellow piece. So I don't know, I'm just going to call it a yellow piece. Oopsie, sorry. So now that we have that yellow piece, how do we find the length of that yellow piece? Well, hopefully you are remembering that we rotated right here. This rotation through here is pi over 12 radians. And if I want to find this value, so in other words, I have this triangle right here. I've rotated pi over 12 radians. I have a right angle right here. I know my radius length is 30, and I'm trying to find this length right here. And that's the vertical length, so that's my y value. How do I find my y value? I just take sine of this angle measure equals y over 30. Because this radius is a length of 30, that means it is 30 times bigger than a unit circle. So I can just multiply sine of pi over 12, which would be the y value of a unit circle, just multiply it by 30 because it's 30 times bigger. So if you plug this into your calculator, you will get a numerical value. But here, I don't know why my eraser's not working. Sorry. So here, what do? I just substitute in this value right here. So it's my yellow part would become 30 times sine of pi over 12. Now, actually, if you want to use your calculator and calculate that, you need to make sure your calculator is in radian mode. So you have to go to your mode and make sure you're not in degrees, but you are in radians. And if you were to calculate that, then you would find that, let me see, I'm going to calculate it right now. And I would add 40 plus that value, and I would get, sorry, let me change a different color, 47.76457 roughly feet above ground. So this portion right here was roughly 7.76457 feet. So this entire distance was 47.764 or 0.765 feet if you were to round or truncate to 3 decimal places. Okay, if you're not sure about that, ask your neighbor. You can pause and ask someone to help you, ask the substitute, maybe they can help you, or you can go back and re-listen to that explanation and try to follow it again. Or you can also stop into the math center and ask them. The next one, hopefully, is not as challenging. So let's figure out this next one. So we go back to this diagram, and we are going to figure out pi over 2 radians. Well, if we rotate this pi over 2 radians, hopefully you realize you are directly above the center. So you're directly above. So then this one is not as difficult. It's 40, because we know from here to here is 40. So we know this distance here is 40. And then we're adding, because it's directly above, we're just adding what right above it? Well, that's just the radius. So what is the radius length? The radius length is 30. So it's 40 plus 30, so that would be exactly 70 feet above. So point P up here would be exactly 70 feet above. So the diameter of this Ferris wheel is 60 feet, and then it's 10 feet above the ground. You are welcome to have a little pause here and try these on your own. So go ahead and draw the picture. Where would P be? So P, if we rotated 5 pi over 6 radians, we're going to go around. This is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So this is roughly 5 pi over 6 radians that I just rotated. If you were to extend this length right here of P, right, we can just make it a horizontal, then this is your angle measure that we're looking at, or you just drop this right angle. Remember, this is still a distance from the center down to the ground. This is 40 altogether, or we know this is 30 and this is 10, or it's 40. So now I have to find this red portion up here, and then I can add 40 to it. So how do I add, or how do I find this red portion right here? Well, use your trigonometry. How do you find this red portion right there? That's the y value. So what am I going to do? Well, if you draw that triangle over here, I rotated 5 pi over 6. So, and this is 30 because the radius is 30. So we know it's 30 times bigger. To get the y value, I just take sine of the angle measure that I rotated. So if I take sine of the angle measure that I rotated, I'm going to get my y value, but then the triangle is 30 times bigger, so I have to multiply that by 30. Or you could say sine of the angle measure that's opposite over the hypotenuse, but then I'm going to multiply each side by 30, so I get 30 times sine of 5 pi over 6. So in the end, point P would be this distance off the ground, which is the yellow portion, which is 40, and then adding this red portion right here, which we just said would be 30 times sine of 5 pi over 6. Well, sine of 5 pi over 6 is what? Sine of 5 pi over 6 is 1/2. So 30 times 1/2 is 15. So 40 plus 15 is equal to 55. So that would have a distance of 55 feet above the ground. Now try the next one. Try to set it up. Do the rotation and see where D will be. Pause and try that on your own first. Okay, so this one's a little bit trickier. When you rotated 5 pi over 3 radians, did you get a point P down here in this fourth quadrant, or down here where my P is located? So it should be down there somewhere. So we have 1/3, 2/3, 3/3, 4/3, and then this is 5/3 right here. So we rotate 5 pi over 3, and we're ending here. Then I draw this triangle right here. So I'm looking at this triangle, right? So I rotated 5 pi over 3. I know that I have a radius length or hypotenuse length of 30, and I am trying to find this length right here. That's the y value. So how do I find the y value given this is my angle? Well, in order to find the y value, I take sine of that angle measure, which is 5 pi over 3, because I rotated 5 pi over 3, and that's my y value over my hypotenuse. Or remember, the radius is 30 times larger than a unit circle, so I'm just going to multiply 30 times sine of 5 pi over 3. Now here's the issue. When I plug that into my calculator, so practice plugging it into your calculator. Remember, your calculator needs to be in radian mode. When I plug that in, 30 times sine of 5 pi over 3, I get negative 25.98076. Why is it negative? Because it is going down. This is assuming that this is my x-axis. I am going down negative 25.98076 feet. But that's not the question. The question is, how high is P from the ground? Well, if this entire distance from the center to the ground is 40 units, what do I do with 40 and negative 25.906? Hopefully you realize 0.9807, sorry, I don't know why I said 906, but we would take 40, we would subtract 25.98076, and then you would get your answer doing that. So when I do that, I get 14.019 feet. So that is the distance from the ground to point P. which you can see it's a little bit above. We knew this was 10 feet when we did that in an earlier question, so that's just a little bit above. So yes, that makes sense. So you can always have a little pause and ask yourself if that makes sense. All right, look at this one and try to draw this on your own. It says the center of a Ferris wheel, again, is 40 feet off the ground. It's the same question, and the radius is 30 feet in length. Then you are going to try, as P goes around the Ferris wheel, estimate which angles of rotation put P 60 feet off the ground. So try to draw where P would be if it were 60 feet off the ground. So I want you to pause and try that on your own. Okay, so look what I did here to estimate this. So I knew that I have this length here, which was 40 from the ground to the center. Then I knew that the radius length was 30, so I remember from previous question that we said the distance from the ground to the top is 70. The distance from the ground to the center is 40. And then I just pretended that this was like an y-axis, and I just went up it and I just tried to even it out and make a 50, a 60, so I could see what was happening there. I made an approximation of 10 units per. So then I said, okay, this is about 60 right here, and then I drew a horizontal line, and I have two locations. One is this P on the right-hand side, one is this P on the left-hand side. So it says estimate which angles, so there could be two and there are two, which angles of rotation would put this 60 feet off the ground. Well, this looks like it's almost splitting this right in half. So I'm gonna approximate that that is roughly rotating about pi over 4 radians. That's my first one for P prime. For P double prime, I'm going to keep going. That would be 1 pi over 4. That would be 2 pi over 4. This would be 3 pi over 4. So P double prime, I'm approximating that it's rotating 3 pi over 4 radians because it's 1/4, 2/4, 3/4 roughly. It's not exactly, but it's just an approximation. So again, how did I do that? I knew this was 40, I knew the top was 70, and I just thought of this as a y-axis and evenly dispersed it, drew my horizontal line across, and it looked like it was splitting it in half, which means it's about pi over 4. Okay, so our lesson synthesis. Remember we were trying to find points around the circumference of the circle using sine and cosine. Really what we did was we used sine because it was the vertical portion only. If we needed the horizontal portion, we would have used cosine. So let's look at this lesson synthesis. It says, suppose a wind turbine is 200 feet tall to the top of the base. So that means this portion right here is 200. And it has 3 blades that are 120 feet long. Now, I know already that this 120 feet long, if it was going to the top, that means this entire distance would be 320 feet. Okay, then it says, what is the highest and lowest the windmill blades reach? So what would that be? You can see this diagram here. Well, I just said the highest it would reach would be 320 feet, right? Because it's the 200 plus the 120. Oops, that looks funny. So 200 plus 120, so that would be 320 feet. That's my maximum or my highest point. My lowest point, what would I do? So my lowest point would be what? So I have 120, but if my blade is going down this way at 120, then what is this extra distance? What is in between here? Well, hopefully you were saying to yourself, oh, I'm going to take 200 and subtract 120 feet. So that would be approximately 80 feet for the minimum point. So my maximum is 320 feet and my minimum would be 80 feet. Okay, the next part. What angle would the windmill blade make in the highest and lowest position? Well, in the highest position, it's pointing straight up, so that would have rotated how far? Remember from the positive x-axis? it rotates pi over 2 units, so that's for the highest. It would have rotated an angle measure of pi over 2 radians. For the lowest, it's rotating around to this, so what is that going to be? Well, it's pi over 2, pi, and then 3 pi over 2. So the lowest would be 3 pi over 2 radians. Okay, what does the expression 120 sine pi over 4 represent in this situation? Ooh, what does the expression 120 sine pi over 4 represent in this situation? Well, where is pi over 4? If we're thinking again of this as a positive x-axis, or sorry, the x-axis and the y-axis, where is pi over 4? It's right here. So sine of pi over 4, this is pi over 4 units for that angle measure. Sine of pi over 4 is just the vertical component. Why is it just the vertical component? Because sine of an angle measure is equal to the y value. And so if I take 120, remember instead of it being a unit circle where the radius length is 1, it's 120 times larger. So it's 120 times sine of pi over 4. So that is then giving us the length of only this green portion, right? So that's what it represents. It represents the length from the top of the wind turbine to the tip of where that, where the blade would have rotated. So from the top of the wind turbine to the top, or to the tip of the blade for the wind turbine. So that's what it represents. So you need to write that in your own words. So it represents the distance from the top of the wind turbine, or sorry, the middle of the wind turbine to the tip of the blade. And how high is the tip of the blade when it is at an angle of 11 pi over 6 radians? I would love for you to calculate that on your own, and then you can unpause and check it with me. So calculate that first on your own, then unpause and check it when you're done. Okay, did you get 180 feet? I hope so. So you can see up here, first, I made the angle of 11 pi over 6 radians. So I had to rotate 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi gives you pi, and then 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. So I'm in the fourth quadrant down here at point P. So I rotated to get point P. Then I made my right triangle. I'm looking for this vertical piece right here, right? So when I took that vertical piece, I calculated that by doing 120 times sine of 11 pi over 6, which gave me negative 60. Again, why is it negative? Because it was, if this is the origin, right where that center is of the wind turbine, then I'm going down 60. And I want this yellow height up here, this yellow height. So what do? Well, it was 200 from the ground to the center, and then I have to subtract this 60. And so when I take 200 and subtract 60, I ended up with 180 feet. So again, if you're not sure, ask your neighbors, you can ask another Algebra 2 trig teacher, Miss Lee, Miss Price, or Mr. Ngowe, or you can stop through the Math Center to get some extra help. Now you can have a little stretch. I'm going to pause here and then I'm going to do the next lesson. So you can stretch or you can just keep continuing, but it'll be a different link since this took a little bit longer than I was hoping. All right, part 2, the rising and falling, day 4, lesson 8. We're going to work on our second goal. Our second goal is to understand that the graph of a periodic function can look like the wave whose outputs repeat between the same maximum and the same minimum. So I have a little reminder for you here. What is a period? So we talked about a periodic function. Well, a period is the length of the interval at which a periodic function repeats. So if it is periodic, then it's going to have a period. That means every certain amount of time or every certain interval, you are going to have the same exact look of the function repeated over and over and over again. So keeping that goal in mind and knowing what a period is, pause right now and look at the notice and wonder, and what do you notice with respect to that goal today? in this diagram. So go ahead and pause and think of some things on your own.